Hi everyone, welcome to our strategic field program project. My name is Cory Jacob. I'm a crop extension specialist at the Acknowledged Center Moose Jaw, and with me is Clark Brenzil.
I'm the weed control specialist out of Regina for the Ministry of Agriculture, and we're standing in front of a plot here where we're looking at the impact of seeding rate and row spacing on competition with weeds and various different yield components of the crop.
We have a very kind of herbicide mentality. Not that herbicides are bad, but it's also to get us thinking more with herbicide resistance and our issues with herbicide resistant weeds to get thinking more kind of about good old agronomy and seeing what we can use through agronomic practices to compete with weeds better on an agronomic level without really organically, you could call it, and then B, to also look at secondary growth characteristics, so tillering, which is one factor when it comes to harvest management in cereals, especially when we see the microscope that glyphosate has been under and how it's been scrutinized and looked at. So just to get producers thinking a little bit, trying to kill two birds with one stone with agronomics and crop maturity in that regard. We asked each AgriArm site to pick a wheat variety or durum variety that was kind of common to their area. So the project is spread over 5 different AgriArm sites in the province. So we're at Outlook here with ICDC, one at Surf in Redvers, one at iHarf in Indian Head, one site at Swift Current at the Wheatland Conservation Area where they are growing durum, and then at the Conservation Learning Center in Prince Albert. We designed the trial to basically have a narrow and a wide row spacing. So at ICDC here, they're on a 10-inch spacing, so we asked them to go a 10-inch and a 20-inch spacing. With equipment limitations, that's really what we can do. iHarf was the only one where we were able to, with your seeding equipment, varied up a little bit, where we did a 10, 12, 14, and 16-inch row spacing. So a little bit of a larger trial, a little more data there. And then for the seeding rates on the wheat, we varied it up, going with a standard 100%, which would be 270 plants per meter squared, a 75% of that, which would be about 200 plants per meter squared, 1.5 of normal, which would be about 400 plants per meter squared, and then two times normal, so about 540 plants per meter squared on the wheat. To really test us and to see what we're going to see for competition, really test the crop, and then to see how much we can kind of beat back and suppress the weeds. So in the background here, you can see oats behind me. There's a significant oat population and wild mustard in there as well. Actually, it's tame oats and tame mustard. We were trying to mimic as model weeds without actually introducing the weeds. So when ICDC seeded this, they seeded the crop, and then they cross-seeded the model weeds at 20 plants per meter squared afterwards, just to mimic some good crop competition, really stress the crop, and to really, that's where we're going to get our data from. No herbicide passes. This was a non-herbicidal project, but we did ask for if they were to do a pre-seed burn off, just the glyphosate alone and not a residual project, just to keep everything on an even playing surface, and to have no residual product that might be impacting crop or weeds getting ahead of one or the other.
So what we're looking at in the plot here is a couple of plots side by side that are identical in all ways except for the seeding rate. And so the plot on the left is at the 2x seeding rate. The plot on the right is at the 0.75 seeding rate, really illustrating the impact of seeding rate on suppression of the oats that were the model grass crop in here. And we're not really even seeing in the high density plot, we're not even seeing much in the way of mustard in that plot. So now what we're looking at is the same plot that was on the left is now on the right. So that is our high seeding rate, narrow row spacing plot. And again, everything is identical in these cases except for row spacing. And so our plot on the left here is the wide row high seeding rate. And essentially what we're seeing here is that the narrow rows combined with the high seeding rate are really suppressing the weeds in that plot, whereas the plot on the left that has the wider row spacing is leaving much more area for those weeds to get established and get in and contaminate the crop. Why this is important is, especially for resistance, is that resistance is really a numbers game, and any way that we can reduce the number of weeds in a plot before we go in with the herbicides, the lower we make our risk for the development of herbicide resistance. So with our wide row spacing, we're relying very heavily on herbicides to manage the weeds in that plot. And in some cases where you haven't got a very residual product, you may see weeds come back after because the crop is slower to close in, whereas you can use much less expensive, potentially more contact type products in a higher density and closer row spacing type of seeding arrangement. And even if we compare both our comparison plots here, and we look at the narrow row spacing, low seeding rate, there's still fewer oats in that plot than there is in the high seeding rate, wide row spacing. And so it really illustrates the benefit of narrow row spacing on the suppression of weeds in that crop. And essentially where producers have to make that decision is when they purchase a new piece of equipment. And that typically doesn't happen that often, so it's not something that we can adjust on the fly. And a lot of decisions for seeding equipment have now been made on engineering reasons. So lower draft, more acres covered for the same amount of equipment, lower fuel rates. In the plot that we're seeing here, that's the high seeding rate, narrow row spacing, we're also seeing higher incidence of leaf disease, which is something that we would also expect with the higher biomass accumulation within that plot, and better ability of things to spread from plant to plant, and higher humidity rates within that canopy.
So we thought we'd have a little bit of a discussion about the pros and cons of this trial. You know, definitely we've talked about some of the pros being, you know, weed control on the secondary growth side with tillering less tillers, but there are some cons as well to it. I'll let Clark start with a few of what he thinks would be cons with this.
Well, the real challenge is that for producers to adapt their systems to this, they can do it at several stages through their equipment modification or equipment acquisition process. So they can either do it when they're buying the equipment, or a really easy way, if they're currently on 12-inch spacing, say, and they go with a 4-inch split boot type of seeding system, then they're doing a 4-8, 4-8 row spacing, and they're really gaining the benefits of that close row spacing while still maintaining some of the benefits of the engineering benefits of the draft situation. So they're still on that 12-inch spacing, but they're actually getting closer row spacings by using split boot. Let's assume that we're in these plots and we're actually controlling the weeds that are behind us with herbicides. In the absence of weeds, what we could say about the theoretical change in the crop as a result of the change in seeding is that when you have a higher density of your crop, you're making better use of your seed bed utilization, you've got more evenly spaced crop, whereas if you're piling your higher seeding rate into a wider row spacing, you're getting more intercompetition between plants, and that's where you're going to start getting more of those tillers being pushed out to the side. The other thing in theory that we should see with better seed bed utilization and fewer tillers on each plant is increasing the size and yield of each wheat head. The other thing you're going to get is you're going to get a more even maturity at harvest. So you essentially only have 2 or 3 wheat heads per plant that you really have to get mature, whereas when you have wide row spacing and you have lower seeding densities, now you have to deal with all those secondary tillers and potentially tertiary tillers that aren't mature, and what they're doing is they're drawing energy away from that crop to try and fill those seeds at harvest time. And so now you're looking at very variable maturity, and in that case, in order to get things matured in time for harvest, you have to go into the harvest management applications, and that's another cost that may or may not be necessary depending on how you do the seeding. And so when we're in a season like this where we've had really late emergence of crops and we've got variable stages of crops, that could be the benefit that makes the difference between having a crop in the bin and having it frozen out in the field. So if we have higher seeding rates and less space between each individual plant, now we get a more even maturity and we can get the crop in the bin quicker.
The other point to that is We might also be seeing that non-use, that non-need for harvest aid, which there are MRL implications, as we've been seeing in the last few years with glyphosate, as well. There might be enough of a weed. There will be enough of weed suppression where we might not have a dirty enough field where we would be needing the herbicide as well to get rid of the crop and to dry everything down. So if we're relying on the crop itself to compete with and choke out the weeds, and really plant competition, it's hard to measure, but if you look behind us, they're violently competing with each other. It's just hard to really tell, but they're competing for water, nutrients, sunlight for photosynthesis. It's kind of it's a hard one to really see and to really measure, but there definitely is a benefit there with it, and you really are noticing the crop, higher seeding rates, higher and a narrower row spacing, definitely a little bit stronger, and kind of trying to suppress the oats a little bit harder there too with the model weeds.
Yeah, if you have more competition within those plots, Cory, you're looking at fewer weeds coming back after the crop has already been up and well past that in-crop herbicide timing. And again, you may reduce your need for harvest aid product to come in prior to harvest to try and manage some of those green weeds.
Yeah. No, and I mean, there's other benefits. Maybe we could start talking about maybe less return to the weed seed bank, and looking long term down the road with producers and their operations, and that it's quite a there's more benefits to it than we've discussed, but there's definitely some long term benefits to try and get anyway.
So Cory, maybe you can talk about some of the things that we're measuring in these plots here to give folks an idea of how we're going to figure out whether there's pros or cons to these treatments.
Sure. So unfortunately I do have to do some reading, but we were taking a weed biomass early on. We said about 6 weeks after planting, and that's been stretched a little bit because with the dry season that's been stretched and brought back a little bit, but we'll get a good measurement of weed biomass just to see how well we're actually suppressing the weeds with the crop competition. We asked each site to also do a visual weed assessment just to assess how weedy the plots are on a scale of 1 to 10. Now, when we get into the secondary growth benefits, the less tillering in the wheat, we asked them to do some tillering data collection. So some wheat tiller numbers, so seeing what our differences are between the different treatments. Head length, we should be seeing some different sizes on the wheat heads. Head density, then of course we're going to take it to maturity. We're going to get grain yield and 1,000 seed weight as well. And we're also going to do an extra dockage calculation. So it's basically a calculation where it's very simple. You go 100 minus the percent dockage to get an idea of how much wheat seed production there was out of that specific plot, and to just see the suppressive ability of the crop at those different seeding rates and row spacings. It gives you a bit of an idea of just how much the crop was actually suppressing the weeds. It's just, visually it's hard to measure, but if we can put some numbers to it and some statistics, might make a little more sense to go with the pictures anyway.
Sounds great.
All right, so that is our little bit of an explanation on the trial and what we're doing here. We definitely are excited about the results, and to get the results out and write up the reports and to kind of get it out in the public eye. It is the strategic field program is a publicly funded program through the ministry. So we will be having the results and reports available this winter for viewing. We will also have it available. We'll be doing a follow-up video that'll be available on the ICDC YouTube channel. That's everything, Joel?
Yep. Yeah. Good.
So we've kind of had a bit of a challenging spring here with extremely dry conditions in the spring, and it did hamper some of our growth. And we have thought of some different ways to maybe continue this project or to take it in a bit of a different direction in the future. So we are definitely, I guess, look for other variations or some other changes to the project. We're thinking maybe some narrower row spacings, for example, with one angle to take it with. But with the year we had, we might also change up some locations, seeing who would be willing to come on and do the work that we're asking for the project, and to really, again, get it spaced out in the province in different soil zones and growing conditions as well.